Why, hello there. I'm Professor Plum and I will be teaching you about science! Now, safety first. We need our lab coat to protect us from poisonous and toxic chemicals. And, most importantly, we need safety goggles for our eyes.
Emma, what are you doing?
I'm teaching them about science!
You really need a man in your life.
There is only one man in my life, ladies and gentlemen, and that is John Dalton. Now, let me tell you my stories.
John Dalton was born September 6, 1766 in Cumberland, England. He was an English chemist, meteorologist, and physicist. He was most famous for his work in the development of atomic theory and his work researching colorblindness.
Dalton's Law. Dalton's Law of partial pressure states that the total pressure of a mixture of gases is equivalent to the sum of all the pressures of the gases in the mixture.
So, mathematically, this law can be stated with this formula. P total equals P1 plus P2 plus P3 plus Pn.
I love you like a song, I love. I don't understand.
Alright, for those of you who don't understand, P1, P2, P3, and Pn represent the partial pressures of the gases in a mixture. P total represents the total pressure of a sample of the mixture in the gas.
I get it now! My milkshake brings all the boys to the yard and they're like, I'm better than yours, well damn right, I'm better than yours. I don't really understand what partial pressure is.
Partial pressure is the pressure exerted by a single gas within a mixture of gases. This was discovered by Dalton in 1801.
At sea level, air pressure is 101.3 kilopascals. And what does air consist of? Well, air consists of nitrogen, oxygen, water vapor, argon, and carbon dioxide. All these elements make up our own mixture of air that we breathe in every day, which is 101.3 kilopascals. Okay, so we know the total pressure is 101.3 kilopascals. We can then figure out the pressure of each individual substance. So, we've got nitrogen is 68.1 kilopascals. Oxygen gas is 20.9 kilopascals. Water vapor is 1.28 kilopascals. Argon is 0.97 kilopascals. And lastly, carbon dioxide is 0.05 kilopascals. So, all these elements, when you add them up together, would equal 101.3 kilopascals, which is seawater. This is an example of Dalton's Law. Any questions? Check this experiment out. Watch the oxygen disappear and take the flame out. Oh, thank you. Thank you. Well, that's our show, and thank you for staying tuned on our program about
Dalton's Law.
Dalton's Law. Now, may I interest you in some potassium?
It's raining men. Hallelujah. Hey, Emma. This is Jackson Whistler, reporting live for Shandale's chemistry class. I was just wondering if I could talk to you for a few minutes.
Yeah, absolutely.
Oh, perfect. We're calling inside. I was just wondering if you could talk to me about Dalton's Law and partial pressures.
Well, basically, Jackson, it's a bunch of different pressures combined.
Oh, that's pretty cool.
Yeah.
Thank you very much for talking about
Oh, you're welcome. Have a nice day. Stay classy.
it. It's raining men.
Dalton's Law. Dalton's Law of partial pressures.
Says
So, at sea level. Dalton's Law. Dalton's law of partial pressure states that the total pressure of a mix at sea level, the air pressure at I'm gonna pee myself. My partial pressure brings all the boys to the yard and they're like, I'm better than yours. Well, damn right, I'm better than yours. So please bring that partial pressure to my door.